6.1, ratios and proportions. We started to kind of get into chapter 6, talking about similarity. First thing we're going to do is kind of do a little review on ratios and proportions, as that plays a huge part in chapter 6 when we talk about similarity. So, a ratio, comparison of two or more similar items. A lot of times we talk about the ratio of students to teachers, or people with blue eyes to people with brown eyes. Here you can see I did the ratio of angle 1 to angle 2 to angle 3. And that'll come more into play here as we get into the examples. We'll see that in a little bit. But a ratio, you're just comparing two similar things. We can set up as a fraction. We can set up using the colon from your English class. Not just an organ, but also a piece of grammar. You gotta like that. Proportions. What are proportions? Proportions are equations showing that two ratios are equal. 1/2 equals 5/10. That's a proportion. 2 over x equals 3 over 6. That's a proportion. You're probably familiar with how we solve proportions. If you're not, we use a little method we like to call cross multiplication. So we're going to do some cross multiplying, probably some basic stuff to begin with, and we'll get a little more in depth, a little bit harder as we go along. So that's what we're going to take a look at right now. A couple of examples. Again, if you want to pause the video and get your examples written down and follow along as we go through and solve them, you can. If you want to try to solve them on your own, just keep the video paused and then check and see if you've got the right solutions. That's just fine. So now would be a good time to do that. Okay, we're back. So the first example we have here is 2 over x equals 3 over 6. Cross multiply, we multiply diagonally. So 3 times x is 3x. 2 times 6 is 12. Notice here that when we do our cross multiplication, we're not setting things back up as a fraction. Okay, it sets up as an equation. So multiply one way, multiply the other way. In between, you should have an equal sign. So we get 3x equals 12. Not a real big mystery here. X is going to equal 4 once you divide. In example 2, you've got 4 over x equals 7 over 5. So again, we cross multiply. 7 times x, 7x. Equals 4 times 5, which is 20. Divide both sides by 7 here. We come out with a fraction for our answer, and that's fine. Nothing wrong with that. Fractions are your friends. They help you out. You can get fractions for the answer for proportion. That's just fine. So those are kind of the basic types of proportions you're going to see where you just have a variable by itself in one of the fractions. In problem 3 here, also, we start adding some variables, changing things into expressions. 3 divided by y plus 2 equals 2 divided by y. So again, same process, we cross multiply. 3 times y is 3y. Here when we multiply the 2 and the y plus 2, we need to make sure that we distribute. Whether you start off by writing it like this, or you go ahead and distribute as you're cross multiplying. Either way is fine. You got to do what's comfortable for you. Just make sure that you distribute. So we know that 3y equals 2y plus 4. And so if I subtract 2y from each side, I know that y equals 4, and we're done. Example 4. Y minus 3 over y plus 2 equals 11 divided by 5. So again, we've got more cross multiplication here. We've got more distributive property. 5 times the y minus 3. 11 times the y plus 2. Again, totally up to you. You want to set up where you can actually see the distributive property? Go for it. If not, you can distribute as you're cross multiplying. We should come out with 5y minus 15 equals 11y plus 22. So if I subtract the 5y over, that's 6y. If I subtract 22, that's negative 37. So I know that y equals negative 37 over 6. Amazing. Alright, so that's kind of a big step in terms of proportions and solving proportions. Our last example here kind of gets into some ratios of angle measurements within a triangle. It says the ratio of the measures of 3 angles of a triangle is 5 to 7 to 8. how big are the angles? Typically, when we've got the ratio of 3 angles, we know that class is over. No, you're on break already, so it's just the bell saying it's time to go home, I think. You've got these ratios. You know the 3 interior angles of a triangle should all add up to equal 180. But what we're going to do is we're going to take each number within that ratio and use it to represent the coefficient of a variable. And they'll all have the same variable. So I know that if I add 5x plus 7x plus 8x, my 3 angles, if I add those together, that should equal 180. So 5 and 7 is 12, plus 8, that's 20. So 20x equals 180. Divide. I know that x equals, let me see, that's going to be 9. So now if I take 5 times 9, I know that one angle is 45 degrees. I know that 7 times 9, another angle is 63 degrees. And I know that my last angle, 72 degrees. If you take all 3 of those angles, add them up, you should get 180. So we can have ratios of size as well. Usually we kind of set those equal to whatever the perimeter might be. But that's about it. There is one last example I wanted to show you. Kind of takes you back to Algebra 1 for high school credit. We cross multiply, we got x plus 1 over 6 equals x minus 1 over x. So when I cross multiply, I get x times x plus 1 equal to 6 times x minus 1. When you distribute x times x is x squared, x times 1 is x equal to 6x minus 6. That's easy. You've got x squared, you've got x to the first power. This is called a quadratic equation. You take everything over to one side. So I'm going to subtract 6x and add 6. I'm going to subtract 6x and add 6. When I do that, x squared minus 5x plus 6 equals 0. Key thing here, you want to factor. X squared breaks into x and x. Plus sign says, hey, go check out the middle guy. That's a minus, so both of these are minus. Factors of 6 that add up to 5, 3 and 2. Set each factor equal to 0 and solve. So x equals 3, x equals 2. Machine will be proud if you guys remember how to factor. So that's it for the notes. Go back, rewind, take a look again if you need to. We'll start getting this stuff on Monday when you get back. Hope you guys have a great break and a good Christmas. See you in January.